How does a mass spectrometer measure mass? By Sarah McMahon. Before we begin, let's briefly review the history of mass spectrometry. The mass spectrometer first began with an English physicist by the name of Sir Joseph John Thomson. In the late 1800s, he had a theory that cathode rays are rays of charged particles that hold different masses. He hypothesized that matter, whatever its source, is composed of the same subatomic particles that are smaller than the atoms they make up. To test his theory, he conducted an experiment using a cathode ray tube to study the nature of these channels and the electrical current that is associated with them. He discovered that these rays were in fact composed of subatomic particles that were present regardless of the type of gas tested to carry out the electrical charge. He called these charged particles electrons. In the early 1900s, with the use of cathode ray tubes, he created the first mass spectrometer to determine the electron's ratio to mass. This new device consisted of ionizing particles and sending them through an electrical field and a magnetic field to record how these particles are deflected based on their charge and mass. Sir J.J. Thomson revolutionized the fields of atomic and nuclear physics along with the discovery of elemental isotopes. Throughout history, the mass spectrometer has evolved and continues to evolve to have many uses such as application towards environmental analysis, pharmaceutical analysis, forensic analysis, metabolomics, and proteomics, and beyond. Our learning goals. What is a mass spectrometer? How does it work and measure mass? Okay, but what does this actually mean and how is this relevant to you? Here is a simple example of the science behind it all. So here we see the sample is placed into a vacuum chamber to become vaporized by heat and then ionized. Ionized substances are accelerated by shooting them from the vacuum chamber into a powerful electrical field. The ions are separated this way based on the charge they have. Highly charged equals high acceleration and vice versa. The accelerated ions are shot from the electric field into a magnetic field. When passed through the magnetic field, they bend in an arcing formation. The lighter and more positively charged particles bend more than the heavier and more negatively charged particles. Each ion is bent in relation to its electrical charge it holds in its mass. After these steps happen, an electrical detector records the data from the spectrum that is produced, illustrating how many ions were categorized according to the mass and electrical charge. Now for the blow dryer analogy. Here is a simple analogy of a blow dryer pushing a ping pong ball, a golf ball, and a pool table ball, which in here is called a snooker ball, to represent how the spectrometer identifies the atoms and molecules by mass. When the blow dryer is off, we can see here that the balls of 3 different masses roll straight down, all with a score of 0. When the blow dryer is on, the balls are deflected according to their different masses. The blow dryer represents the magnetic field. Here is an example that helps show us how mass spectrometry might be used in the real world through environmental contaminant analysis. Environmental scientists use mass spectrometry to analyze contaminants in the air, drinking water, wastewater, soils, sewage sludge, and in other areas. In order to protect our human public health and the health of our natural world, these contaminants need to be controlled and maintained. These toxic substances can consist of inorganic anions and cations, heavy metals, persistent organic pollutants, hormones, pesticides and herbicides, personal care products, and pharmaceutical products. These contaminants are strictly regulated by the U.S. federal and state governments due to their harmful nature. Here's an example of a modified version of a mass spectrometer called the Agilent 7010 triple quadruple GC/MS system. This instrument produces more ions for a given injected concentration and draws a higher percentage of those ions to the detector, providing environmental scientists with a very valuable tool for detecting these trace chemicals in complex environmental situations. So now let's review our learning goals. We learned that a mass spectrometer is an analytical technique used to produce a mass spectrum of any substance by ionizing the sample and distributing the materials by their mass and charge. We learned that the mass spectrometer machine ionizes the sample and runs it through an electrical field and a magnetic field to separate the substances by charge and mass to then be identified. And we learned that this invention has aided science and humanity for the last century in scientific advancement and survival of said species, with mass spectrometry being applied to environmental issues such as contaminants that have been identified and eradicated. This invention has led to the evolutionary advancements in the scientific community and humanity at large. Thank you for watching.